Welcome back to Graphing Quadratic Functions in Factored Form, Part 2. In this example, we want to graph y equals -2 times x minus 1 times x minus 5. We want to identify the vertex, axis of symmetry, maximum or minimum values, and the y-intercept. Let's get started. We know that a equals -2, which means that the graph is narrow, and it'll open down. Now let's find our x-intercept. For our x-intercept, we want to take our equation and set each factor equal to 0. So that's -2 equals 0, x minus 1 equals 0, and x minus 5 equals 0. Afterwards, we're going to solve for x. In the first equation, there is no x. -2 equals 0. -2 doesn't equal 0. There's no variable for us to solve. So let's go ahead and just cross that out. In our second equation, we have x minus 1 equals 0. To solve for x, we're going to add 1 to both sides, and that's going to give us x equals 1. So our first x-intercept is at 1, 0. For our third equation, we have x minus 5 equals 0. I want to just add 5 to both sides. X equals 5. So our second x-intercept is at 5, 0. Now let's take these points and plot them. 1, 0 and 5, 0. Let's look for the axis of symmetry. So the middle number between 1 and 5 would be 3. Draw your axis of symmetry. The axis of symmetry is at x equals 3. Now that we've drawn our axis of symmetry, we need to locate our vertex. I know that the vertex is somewhere along this line. So the x value of my vertex is going to be on 3. But in regards to the y value, we don't know. Let's take our x value and plug it into our function to find our y value. Y equals -2 times x minus 1 times x minus 5. Once again, we need to take our x value and plug it into our function. So wherever we see an x, we have to replace that with 3. That's y equals -2 times 3 minus 1 times 3 minus 5. -2, 3 minus 1 is 2, 3 minus 5 is -2. So -2 times 2 is -4, and -4 times -2 is +8. So my vertex class is at 3, 8. The y value is 8, so the y coordinate is 8. Plot the vertex. And label the vertex. 3, 8. Now let's use our scale factor, which is -2. From the vertex, I want to go 1 unit to the right. And you might be wondering, Mrs. Orca, is it always 1 unit to the right? And the answer is yes. 1 to the right, 2 units down. Let's also go 1 to the left, 2 units down. Let's graph. And if you look at our graph, notice how there is no point on our y-axis. So we are going to have to find the y-intercept algebraically, which is no big deal. For the y-intercept, you're just going to take the numbers in your equation and just multiply them together. we have y equals -2 times x minus 1 times x minus 5. Once again, take the numbers in your equation, -2, -1, and -5, and just multiply them together. So that's -2 times -1 times -5. -2 times -1 is 2, and 2 times -5 is -10. So class, the y-intercept is at -10. Another way to write that is 0, -10. So let's go ahead and plot a point at 0, -10. And if there's a point at 0, -10, we know that we are going to automatically have a point at 6, -10 because our parabola should be symmetrical. Highlight the graph. We have the vertex, which is done, the axis of symmetry, which is at 3. We have our y-intercept, which is at -10. And the vertex is our highest point, so that's going to be a maximum. A maximum at y equals 8. Okay, so that's how you graph a function in factored form. Let's do one more. Example 4. Graph the function, identify the vertex, axis of symmetry, maximum or minimum values, and the y-intercept. We have y equals negative times x plus 2 times x minus 4. So step 1, let's identify the scale factor. Well, since we have no number in front of our binomial, let's make that number -1. This tells me that the graph opens down and is of regular size. Moving on, let's find our x-intercepts. For our x-intercepts, we want to set each factor equal to 0. So let's rewrite this as y equals -1 times x plus 2 times x minus 4. And once again, we want to set each factor equal to 0. -1 equals 0, x plus 2 equals 0, x minus 4 equals 0. Afterwards, we're going to solve for x. Well, -1 can't equal 0. There's no variable in -1 equals 0. So let's cross that out. In our second equation, we have x plus 2 equals 0. If we were to solve for x, we would subtract 2 to both sides, and x would equal -2. So our first point is at -2, 0. For our third equation, we want to add 4 to both sides, and x will equal 4. So our second point is at 4, 0. Let's plot them. -2, 0, 4, 0. Now we need to identify our axis of symmetry. Our axis of symmetry will fall on 1. So we know that the vertex is going to fall somewhere along our axis of symmetry. Now let's find the vertex. The x-coordinate of our vertex will be where our axis of symmetry is at, so that's going to be 1. But the y-coordinate is unknown, so let's take our x value and plug it back into our function. y equals -1 times x plus 2 times x minus 4. Once again, take that 1, plug it into your x values. So y equals -1 times 1 plus 2 times 1 minus 4. 1 plus 2 is 3. 1 minus 4 is -3. Now we have -1 times 3, which is -3, and -3 times -3 is +9. So the y-coordinate of our vertex is +9. The vertex is done. Let's plot that point. 1, 9. Okay, so now let's use our a value. And for a, we want to go 1 unit to the right and 1 unit down. And if I have a point on the right side, I'm automatically going to have a point on the left side. Lucky for us, our left point happens to fall on our y-axis, which means that our y-intercept is at 8. Go ahead and draw the curve. Highlight the graph and label the parts. Our vertex is at 1, 9. And because our vertex is the highest point, we know that we're going to have a maximum. A maximum at y equals 9. So the vertex is done, the axis of symmetry is done, we have a maximum, and the y-intercept is at 8. Okay, so we've covered everything. If you like this video, go ahead and give it a thumbs up, and don't forget to subscribe.